These next three questions deal with our rotations. So the first one, we're rotating -8, 1 counterclockwise 90 degrees about the origin. Okay, so these are we're going to use our original rules for rotations. Okay, number 9, we're going to change this question. We're not going to go by, because this particular question forces us to use the translation rule for rotation around a point that's not the origin. And we, of course, learned Nicky T's way of doing it. So you have a choice. So for number 9, what we're going to do is we're going to rotate B, point B, 3, -1, and we're going to rotate it counterclockwise 270 degrees. But we're going to rotate it around C, which is at -2, -5. Okay. Question 10. We are, again, and I changed the numbers, and I can change the coordinates so that way it's on our graphing. It fits on our graph paper. So what I'm going to do, so I changed A to -7.5 and B to -2, -3. So we're rotating the first block 90 degrees about point B. Okay, now if you happen to remember, you will not get this on your test, but if you happen to remember that the rotation rule for 90 degrees counterclockwise is -y, x, you can just reverse. So we interchange -8, 1 becomes -1, -8. Okay, for a 90 degree rotation counterclockwise. But if you don't remember, if you have not memorized that rule, remember we're going to draw our rectangle to the origin. And you'll notice that I have a height of 1 and a width of 8. Now when I rotate this 90 degrees counterclockwise, I'm going to, again, we start at the origin, but this time I'm going to have a width of 1 and a height of 8. Because all rectangles have 90 degrees. So point P here comes, when we rotate it, comes here, and that is -1, -8, which we got on using the rotation rule. So this would be P prime. Okay, so I have point B, and I'm going to rotate it around point C. Now, if most of you liked Nicky T's method, so I'm going to do that one first. And that has the less steps. So using Nick's method, what we're going to do is redraw our X and Y axis so that our point of rotation now becomes our new origin. Then I'm going to follow my original rotation rules as if this was the origin. If you notice, when I draw my rectangle to my rotation point, I have 1, 2, 3, 4. I have a height of 4. 1, 2, 3, 4, and a width of 5. So remember, counterclockwise So this is 90 degrees. This is 180 degrees. This would be 270. Every quadrant is 90 degrees and a 90-degree turn. So rotating 90, my rectangle, I would have a height of 5, width of 4. Down here, it would mirror my original rectangle here with a width of 5 and a height of 4. So my third square, I'm going to have a height of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And a width of 4. 1, 2, 3, 4. 4. Yep, so this is 4, this is 5. And now we have to just ensure that point B, we keep track of where point B goes. So it's gonna, point B rotates around the points, around the corners of the rectangle each time we turn it. So, so we go from upper right to upper left to lower right. So this is B prime, which happens to be at +2, -10. Okay. All right, now let me go through the translation method, just in case some of you do want to use that method. So, remember that the point we're rotating around, which is going to be -2, -5, becomes our translation vector. And what we have to do is translate point B, +2, +5. So essentially what that does is you take point B, so I'm gonna go to the right 2, 1, 2. Let me change colors here, sorry. So we can distinguish between. So point B, I'm gonna translate right 2 and then up 5. 1, 2, 3, 4, 5. So that puts point B after the translation at 5, 4. Okay. Notice how the translation is the opposite of my point of rotation. Okay. So by doing the opposite translation, that allows me to then rotate around the origin like we would normally do using our rotation rules and our rectangles. But then we have to move it back. So I would do if you're using the rectangles, I would do the exact same thing I did with Nicky T's version. Draw your 5x4 rectangle, and then, but remember you're going around the origin, so you're using your X and Y axis. I'm not going to redo that again, but this time what I'll do is I will use our rotation rule, and for 270 degrees we flip the X and Y, but this time, unlike the 90 degree, we do the -X. So B at 5, 4 becomes 4, -5. And that makes sense because, again, 90 degrees, 180 degrees puts me in quadrant 3, 270 puts me in quadrant 4. So that's at 4, -5, which is here. So first step, I translated point B using the opposite vector than the point given. Essentially what that allows us to do is it's making up for the fact that we're not. So if I'm rotating around -2, -5, if I move my point 2 units and 5 units in the opposite direction, I'm making up for and putting in the, I'm now putting point B at the origin, essentially, as if it was in the origin. Okay, because if you notice, -2 plus 2 gives me 0, and -5 plus 5 gives me 0. So that translation is allowing me to treat this new green point as if I'm rotating around the origin. Then my second step is to then rotate this green point B around the origin. But then what I need to do is then take that -4, -5 and translate it back. So I'm now going to translate it again. So I have to move it back to where it was. So I actually rotate around -2, -5. So I'm going to move it back to the left 2 units and down 2 units. So if I take my 4, -5 point and go to the left 2 and down 1, 2, 3, 4, 5, you'll see that I do get the same exact answer as using Nicky T's method. All right, and that's question number 9. I have pre-drawn already for question 10. Okay. So this time I'll start with the translation method. All right, so to rotate around -2, 3, I'm going to translate point A, +2, +3, because that's how many. So translating point A, +2, +3 allows me to rotate my point as if it was around the origin. So that's why we do the opposite translation of the rotation point. So that means I'm going to take this point and move it up 2 because it's positive, and to the right 3 because that's also positive. Okay, so now this new point A, I'm going to translate 90 degrees counterclockwise. So using my rectangular method of rotating around the origin, I'm going to draw my rectangle. So that way I have a height of 1, 2, 3, 4, 5, 6. I have a height of 7 and a width of 1, 2, 3, 4. Okay, so when I turn my rectangle counterclockwise once, that's 90 degrees because every rectangle has 90 degrees. So my height of 7 now becomes my width of 7 from the origin. And my width of 4 now becomes my height. and I have a width of 7. Okay. Now, if point A is in the upper left-hand corner, when I turn it once, it's now going to be in the lower left-hand corner. So that's A after my 90-degree rotation. Now, once I've performed my rotation about the origin, I now have to translate this new point A, which is at -7, -4. I have to now translate it back to the -2, -3, that my original point of rotation. So that means my -7 has to go to the left 2 and down 1, 2, 3. So my final answer in A prime is at -9, -7. Okay. Now, let me use Nicky T's method here, and we'll see if I get the same answer. So my point of rotation now becomes my new X and Y axes. Okay, so remember my original point A was here. I need to change colors so we don't get confused. Okay. A is here. So from, excuse me, so from my point A, I am going to draw my rectangle to my green set of axes. And I have 1, 2, 3, 4. I have a width of 5. And I have a height of 1, 2, 3, 4, 5, 6, 7, 8. Okay. So 1 90-degree turn in the next quadrant. When I start from, I'm going to draw a length of, my height now becomes my width. So from here, I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4. 1, 2, 3, 4, 5. Yeah, I'm off. If you guys notice, I'm off by 1. I'm off by 1. So I apologize for that. And if you can find my mistake, please let me know. But when I redraw this triangle with a length of 8 and a height of 5, point A is actually at -10, -8. So you'll notice I'm off by 1, both X and Y. I'm not sure which method I miscounted. My steps are correct, but I miscounted somewhere. So if you find my mistake, let me know. But the method and the steps are sound.